Welcome to my favorite meme. Today I'm going to introduce 13 non-elementary integrals to you. And here's the 13 non-elementary integrals. And here is the first one. The integral of e power of negative x squared dx. And this is very similar. It's really similar of this is called Gaussian integral. The integral of e power of negative x squared, but this time this is a definite integral. It goes from negative infinity to positive infinity, and this is equal to square root of pi. This is a really famous formula, but square root of pi. But this time this is a indefinite integral. We don't have a upper limit and lower limit here. So what's the purpose of doing an integral? Yes, to find the solution to solve the area, right? So why? Another example, ln of sine x dx, and this is impossible to integrate, even is non-elementary. But what if this is 0 to pi over 2, and this is also really famous, and this is equal to negative pi over 2 ln 2. The reason we have an answer is because if we don't have if this is an indefinite integral, and the purpose of this is to find the general solutions to find the area under the curve, right? Like x dx, you just get 1/2 x squared plus c, and you can plot some upper limit, lower limit. Like this. Here is the graph of this. Y is equal to x. Here is the general formula. The area of from A to B, for example, and this is just equal to 1/2, and then put the upper limit and lower limit. 1/2 A squared minus 1/2 B squared, right? However, we don't have a general formula of this. And also, if you plot these answers in Wolfram alpha, you will get the answers, the integral of x factorial dx. Because you just need to find the area under the curve, right? So it does have the answers. But if you want to find the general solution, this is I don't think this x factorial can be integrated, right? It will be very difficult to integrate. But if you plot this integral into this definite integral into the Wolfram alpha, it will actually give you an answer. So let me introduce. The first one is the integral of e power of negative x squared dx is equal to square root of pi over 2. This is a constant. Don't forget the square root of pi over 2 times e out f of x plus c. And then e out f of x, and e out f is a error function. It's called error function. And number 2 is really similar, but this time is e power of positive. Don't have a negative here. E power of x squared dx is equal to square root of pi over 2, but this time is the imaginary version of the error function. Is called e out f I of x plus c. And then number 3, the integral of e power of x over x is equal to ei of x plus c. And this is called the exponential integral. And number 4, the integral of 1 over ln x dx is equal to ly of x plus c. And I forget what its name. And so let's go into the number 5. The integral of sine x over x is equal to s sine of x. Be careful, you need a big letter. Ei of x is a big letter, and then ly of x is a small letter. And the s sine of x is called the sine integral. And the s should be a capital letter. So number 6, just replace sine with cosine. Right? The integral of cosine over x dx is equal to ci of x plus c. And it's called the cosine integral. And number 7 and number 8 are the functions I've discovered recently, and it's called the integral of sinh x over x and cosine x over x. And I saw this function the first time, these two functions. The integral of sinh x over x dx is equal to x plus c. And I don't think please do not do the integral of sinh t over t dt, because the output will be shit. You know what it means, right? Don't do this integral in your school. And number 8, the integral of cos x over x is equal to x plus c, or chi. And shi is hyperbolic, and this is called sinh x is called hyperbolic sine of x, and cos x is called hyperbolic cosine of x, and the x is the hyperbolic sine integral, and x is the hyperbolic cosine integral. And you can also pronounce it as shi of x plus c and chi of x plus c, and up to you. And number 9 and number 10, I think this is the hardest one to remember here. And also 11. Number 9, the integral of psi. Psi square x dx can be integrated, and also cosine square x. It can also be integrated. You just need to use the double angle formula in terms of cosine 2x, right? But look at this sine of x squared. The angle is squared, and this is very, very crazy. The integral of sine of x squared is equal to, at the constant, square root of pi over 2, and the 2 is inside the square root, be careful. And then s of, multiply the reciprocal constant, is square root of 2 over pi times x. And here s is called Fresnel s integral. Let's see. And number 10, the integral of cosine of x squared, also square root of pi over 2, and then this is called the Fresnel c integral of square root of 2 over pi x plus c. And this is kind of hard to memorize, so let's move on to the 11th. The integral of ln of 1 minus x over x. This is really, really crazy. This is equal to negative li2, big letter L. And so like this. Si, ci, shi, chi, they need to be calculated. But I remember it's called. And this is negative li. Big letter L is not li of x, small letter li of x. This big letter, and we have a 2 here. And it's called a parallelism integral. I remember. Negative li2 of x plus c. So number 12, the integral of square root of 1 minus a sine square x, and a, they are main constant here, and not inverse sine, not a sine x with 1 minus the constant times sine square x dx is equal to e of x, and then vertical bar a plus c. And here e is the elliptic e integral. And then number 13, the integral of 1 over the reciprocal of this. The integral of 1 over square root of 1 minus a times sine square x is equal to the elliptical f integral, this called f of x vertical bar a. If you want to pronounce this, you can pronounce this as f of x vertical a. Let's see. So here's all the 13 integrals. If you want to be a mathematician, you can memorize this integral. And I can find these two integral yes on YouTube, but these integral I actually can find. You can check some videos. Check the videos of these non-elementary integrals on YouTube. And this, you can type it on Wolfram Alpha. And if you type this integral, type these two integrals on Wolfram Alpha, it actually gives you this SXI. And please do not put a T here. And that's it. But she you can also, you can put a T inside. DT, right? Because CHIT isn't even a word, right? So that's it.